Recording in progress. So today's topic, first topic is conservation of mechanical energy. Okay. And the simple concept is very simple. That let's say write a question, a case where there is a platform. Okay, there is a platform, and an object is, so this is the platform, and then it's like this. So this is the platform, okay, and a ball is rolled from here. Okay, so it goes down. The height of the platform is h, and it has no friction. No friction. Okay, it has no friction. Now you have to tell what is the velocity when it comes here. So this is u is equal to 0. It is left, and v is equal to what? Speed is what? So the concept is, we can say that when, so let's say the ball is here, okay, when the ball is here, we'll write what are the forces on the ball. The force on the ball is, n will be like this, mg will be like this. Any other force apart from n and mg? Is there any other force apart from force? No. And what is the property of n? N is perpendicular to the surface, so n is always perpendicular to the speed at that point, the displacement at that point of time. For example, if the ball is here, then the normal is acting like this, right? If the ball is here, the normal is acting like this. Understood? It is always perpendicular to the surface. That means at any point, so let's say one more thing. At this point, displacement vector of the ball is in this direction, yes or no? At this point of time, when I raise or no, like if you wait for a small interval of time, in which direction is the ball moving? In the pink direction. This is displacement, right? Right. Let's draw the ball any other place. Let's say it is here. Okay. Then the normal at this point will be like this. Mg will be like this, right? And the displacement vector at this point will be like this. Yes or no? At this, just at this instant. Yes. Or the velocity also. It is in the direction of velocity. At any instant, the displacement vector is in direction of the velocity. Now you tell me, when the ball moves from here to slightly here, is the force of normal perpendicular displacement? Is the normal perpendicular to displacement? Yes or no? Yes. Yahan pe it has moved from here to here. Is the normal perpendicular displacement? Yes. So everywhere the normal is perpendicular to the instantaneous displacement. So this is the concept, that normal is perpendicular to the instantaneous S vector. Okay, instantaneous S vector. Understood, everyone? Hmm? Oh, yes. The direction of instantaneous displacement is same as direction of velocity at that point. Okay, so from in the whole journey from this point to this point, what is the work done by normal? By normal, work done by normal is how much? Correct. So it is 0, because the normal is always perpendicular displacement. Okay, fine. And is there any other force which is doing the work? Yes, W by mg. Okay, so now tell me, in which direction is the mg always? Downwards. So in which direction is displacement? Displacement is actually this and this. Like if you find the displacement vector, it is this, no? So displacement vector is something like this. ये vector है ना बड़ा सा. So let me call this, like I can explain you by two methods. First is this is the displacement vector, right? And the mg vector कैसा है? ऐसा है? Yes or no? And what is the work done by mg? It is force, displacement, and cos of theta, right? So therefore it is equal to, एक तो red vector जो नीचे की तरफ है, yes or downwards, it is multiplied with dot product of this vector, right? And what is the dot product? It is mod of one vector, mod of second vector, and cos of theta. So what is the mod of mg vector? It is just mg. Yes or no? What is the mod of ये green vector का mod कितना है? उसके लिए क्या करेंगे? If you see in this triangle, let's say this whole, in this whole triangle, this angle is theta, and we know this length is how much? So we can use cos theta is equal to h by, correct, that length, right? And therefore that length is how much? Kya? H by cos theta. So the green arrow has a length of h by cos theta. Yes or no? And then it is magnitude of 1, the dot product is magnitude of 1, magnitude of 2, and into cos theta again. This will cancel, and work done by mg will be just mgh. Okay, so this is the first method of understanding why the work done by gravity is mgh. The second method is, I told you gravity is a conservative field, so it only depends on the initial and final position, right? And that's why we have said that, you know, the work done from here to here will be same as work done from, so a and c hai ye agar, a to b and then b to c, right? What is the work done in a to b? If you go directly from a to b, mgh, because the in this from a to b the displacement is also downwards and the mg is also downwards, so it is mgh. And from b to c it is mg cos, अरे ये देख इसमें mg ऐसे है ना और डिस्प्लेसमेंट ऐसे है, so it is anyway zero. Okay, so work, so the second method is work done by ac is equal to work done in ab plus work done in bc, out of it this is 0 and this is mgh. Okay, understood? Sorry. Yes. Work done by normal is 0 if, no, suppose you are in a lift and the lift is going up, then in which direction is the normal acting? But when the displacement is upwards, so will normal do work? Yes, in that case normal will do work. Huh? In this case normal is not. 1 second. Sorry, what were you asking? Because gravity is a conservative field, so the path does not matter. The work done on any path is same. It only depends on initial and final points. Okay. So this was the concept. Now, let us do questions. So see your see in the notebook, see in the phone, WhatsApp. Okay, so I'll be doing problems from there. Okay, a particle is okay. A particle is released from a height h. So a particle is released. So at every point, one more thing, Ke plus P is constant. Okay. So particle is released from a height h. This is question number 79. Okay. Okay. At the highest point is released. Released matlab what is the initial Ke? Make the diagram, everyone. Is point pe what is Ke? 0. Pe mgh. Very good. At this point, what is Ke? Very good. Mgh. And what is Pe? 0. They're saying at some point it's Ke. So therefore, at any point, Ke plus Pe is mgh. And they're saying at some point, question mark, the Ke is 2 times its Pe. Yes or no? Ke is 2 times its Pe. Okay. So what is the sum of Ke and Pe now? In mgh, still mgh, right? And if so, I should write the Ke at this point plus P at this point is mgh, right? और Ke कितना टाइम्स है Pe के? 2 times. तो ये टोटल हो गया 3 Pe. 3 Pe is equal to mgh. Yes or no? So therefore Pe कितना है? mgh by 3. इसका मतलब ये हाइट कितना है? What is the height? h by 3 है ये. Understood? Because P कितना है? mgh by 3. So therefore this height, the height of this point P from ground is h by 3. Yes or no? Yes. Now, how will you find the Ke at this point? It's very simple. Just put P in this equation. In this equation, put P is mgh by 3. So you will get Ke is equal to 2 by 3 mgh. Because this will go that side and you will get 2 by 3 mgh. And what is Ke? It is half mv square is equal to 2 by 3 mgh. V square is equal to 4 by 3 gh. So V is equal to 2 gh by 3 ka whole root. Understood? Guys, have you understood? Right fast. Okay. There are some questions which are like 83 easy. 83 may there is a hill made, some hill made, and point A, point B, point D is the lowest most point, and the heights of these are 2h, 3h by 2, h. And it is said that at point A, there is a speed, इसका already speed u है of the circular track. Okay, इसका speed already u is exists. Okay, so what is the energy at point A? It is mg into 2h plus half m u square. ये total energy A पे है. Further, it says that when it slides down, there is no friction anywhere. If there is no friction anywhere, B पे भी energy होगी, C पे भी यही होगी, D पे भी यही होगी. What they are saying? What is the speed at point D? To answer this, you don't need to do, and you don't need to have knowledge of B or C. Simply just go to D. What is the height of D? 0. So what is the P at D? 0. So this is equal to P at D, which is mg into 0, plus half m v square, where v square is the speed, v is the speed at D. Okay. और इसको सॉल्व करोगे तो v का वैल्यू आएगा, करो अपने आप करो, v का वैल्यू आएगा, you will multiply 2 divide by m everywhere, you will get u square plus 4gh का स्क्वायर रूट आएगा. अपने आप करो, देखो मत उधर. योगेश, कीप योर वीडियो ऑन. Done. Hmm? They are saying that the speed at A is u and its height is 2h. If it falls without friction, what is the speed at D? The D is on the ground, the height of D is 0. The concept which you are using is the PE plus KE at this point is equal to PE plus KE at this point. The PE at this point, the A point, is mg into 2h. The Ke at this point A is half mu square because it is given that the speed of the object at initially is u. And they're asking what is Pe plus Ke here. So Pe at D is 0 because the height is 0, it is ground at ground. And what is Ke at D? We don't know. So we are using this speed as V and doing half mv square. And then you have to do this plus this is equal to this plus this. They are equal because Pe plus Ke is constant term. For any point it is same, okay? टू, अरे ये टू इधर भी हाफ है ना, ये मल्टीप्लाई होगा ना, टू हर जगह टू मल्टीप्लाई करो इस इक्वेशन में. Yes, you equate mg into 2h plus half mu square. Have you done it yourself? अब यहाँ पे हाँ वो जीरो हो गया ना, नहीं लिखा मैंने उसको जीरो. कौन सा m? ये देखो, ये नीचे देखो, ये सही समझ में आ रहा है, ये सही है. हाँ ठीक. कट जाएगा अभी. m गया हर जगह से, यस और नो? अरे भाई सब जगह सब में m है इसलिए चला गया m. तो फिर 2 मल्टीप्लाई किया हर जगह तो ये हो गया g इंटू 4h इज इक्वल प्लस यू स्क्वायर. अपने आप करो, तुम्हें दिख जाएगा सीधे. मेरा देख के क्यों करते हो, मैंने जो लिखा हुआ है. 2h थोड़ी ना जीरो है. 2h कहाँ जीरो है? 2h तो 2h ए की बात कर रही हो कि डी की बात कर रही हो? तो डी में तो जीरो है ही, वो तो जीरो यहाँ पे नहीं लिखा ना, यहाँ पे जीरो है. अरे भाई ये क्या है, ये बता क्या है, ये टर्म क्या है? हाँ कहाँ का? ए का. ये क्या है? ये क्या है? ये क्या है? ये डी का पी प्लस के है. कॉन्सेप्ट तो समझो पहले क्या है. दिस v is for d, this u is for a. Left side is a, right side is d. Okay, now there is a question which is like, the question is, right, there is a pendulum. Acha, by the way, in a pendulum, if the length is L, and right, if it rotates by theta, then about, so this point is fixed, right? And this pendulum can rotate in a, and this shape is a circle, right? So therefore, what is, if you make a triangle like this, hypothetical, okay, is this position 1 and position 2? Position 2 is higher in height than position 2, right? Position 2 is higher, right? So we have to find by how much higher, okay? So how do we do it? You make a triangle. Can you see a triangle, Kevin? तुम्हें क्या करना है? मिस सर खाली बैठे हैं, कर लो क्या, 1 घंटा खाली रहेंगे, फिर फिजिक्स मैथ कर लो. Okay, in this triangle, in a right angle triangle, if this is L and this is theta, then you know it is L cos theta and this is L sin theta, right? So what is this height then? L cos theta. प्लीज थोड़ा सा यूज कर लो, थोड़ा सा सोच लो. अपने आप ट्रायंगल बना के करो, तुम्हें आ जाएगा. देखो मत उधर, अपने आप करो, लिखो अपने आप. मेक अ ट्रायंगल, हाइपोटेन्यूज को L लिखो, एक एंगल थीटा लिखो, फिर ट्रिग्नोमेट्रिक क्लास 10th का यूज करो, आ जाएगा. वन साइड इज L cos थीटा, वन साइड इज L sin थीटा. Don't just see, write yourself. You have written the triangle. This triangle you have written. Now understand why this is L cos theta and why this is L sin theta. Have you understood? So write right. This is some base B. Then write cos theta. What is cos theta? What is cos theta? Write that in your notebook. You write no. Hello. ये तो केबिन में रख दो. I'm taking a break. Okay, guys.